Hey, serverless friends, and welcome to another Azure Functions University lesson. This time, Christian is going to tell us all about durable functions, and this is the second lesson for durable functions. So we're going to see some advanced use cases. So welcome, Christian. How are you doing?
Fine. Thanks for having me again for another session about durable functions.
Well, yes, I think it's both our favorite topic, right? So yeah, I was very happy to have you here again talking about it. So yeah, I've used it so much, and I think you use it maybe also on a daily basis, or is it maybe a bit too much? Maybe,
not too much in the recent weeks, and since I changed, but yeah, still in love with them.
Exactly. Nice. All right. Well, before we start the lesson, let's briefly have a look at the GitHub repo. So if you want to follow along with this lesson or want to look into the other lessons, please go to this link. It will bring you to the Azure Functions University repository, and that has a lot of information in there. We currently have quite a bit of different lessons, different topics, but also across different languages. We're still building out the .NET languages and also the TypeScript lessons now. But we're also still looking for contributions. So if you want to help us prepare a lesson around .NET 6 or around TypeScript or PowerShell or Python or even Java. We don't have Java yet, but that's also supported in Azure Functions. So please feel free to reach out. Please make sure you look into the existing issues we have now, because there are some content request issues there already. So some people are working on things. So maybe you can contribute there, or otherwise you can submit a new content request idea there. All right, let's get back to you, Christine, and let's talk about the lesson of today.
Yeah, let's dive into Azure Durable Functions. You should see my screen now. Yeah, yeah. As already mentioned in the introduction, we will talk about advanced patterns of Azure Durable Function. There is already one session about the introduction to Azure Durable Functions. So this time we will take a look at some patterns that are possible with durable functions and that allow you some very sophisticated use cases. And what we will be looking at is the fan-out, fan-in pattern. We will look at sub-orchestrations, and we will look at external events and human interaction. So how can you, when you model something like a workflow, introduce human interaction into the game? Yes, so let's start as usual with the prerequisites. It's the usual suspects when dealing with durable functions. So we have the Azure Storage Emulator, Azurite, that we need because the state of the functions has to be stored somewhere. We use the Storage Explorer just to take a look behind the curtains, so what's happening behind the scenes. And of course, you need something where you can develop, so an empty folder, your Azure Function Core tools, Visual Studio Code, that's what we use with the Azure Functions extension, as you will see, and the REST client for VS Code. And in this session, you will see quite some tricks with the REST client that I learned from Mark, which give you basically superpowers with the REST client. Yeah, and with that, we're good to start. And in order to have something where we can work along or where we can move along, we thought about a little scenario that we will use and that we will implement. And that's one of the employee onboarding. Mark just had an employee onboarding. I also had an employee onboarding in the middle of last year. So we're now experts in that. And usually that's something that could be heavily automated. So if you think about you becoming a new employee in a company, basically the master record of your data has to be stored, and then a lot of other steps could be executed. And we picked up 3 that we want to use in order to work with these patterns that I mentioned before. First one is the triggering of creation of an access card when accessing company buildings is a topic again. Start purchasing IT equipment, which is always fun, especially when there is some shortage in semiconductors, and then sending out an email with a welcoming text and telling you what will happen at the first day when you start. Now, thinking about that and thinking about the last lesson that we had, and I will shift this now a bit to the side. Last time we had durable functions and we modeled a sequence. So when you think about these 3 steps, well, we can use the pattern again. So we have a starter, we have an orchestrator, and then what we did last time, we triggered activity 1. We waited until it was finished, then we triggered activity 2, and then we triggered activity 3. Well, of course, we can do that also with an onboarding process, but that only makes limited sense, right? Because the steps that I just mentioned, they are not interconnected. So I don't need to wait for the result of the creation of the access card in order to purchase the IT equipment. It would make much more sense to do that in parallel. So that's the idea when we talk about the fan out, fan in pattern. So what we want to achieve is we get some basic data as input, and then we want to execute the activities in parallel. Of course, we want to wait until everything is finished, because only then we know that everything that the employee needs in order to start is there. And that's exactly the fan out pattern, of course, and then fan in, because you have to sync at some point in time. And that's the first pattern that we will take a look at in this session. Now, having said that, we will not do any sophisticated logic around the 3 activities. Basically, we say these are activities. You will be calling some downstream system whatsoever. We will kind of simulate it by doing a very sophisticated console log within the activities.
Makes sense, yeah.
Yeah, I mean, the point is to learn the patterns and not to learn how to call a downstream system.
Exactly. Yeah.
That we did in the first lesson. So if you are interested in that, in retrying and circuit breaking something when you have external calls, then the first lesson got you covered. And now, yeah, enough talk. Let's do some code. And yeah, starting with our Azure extension, we will now create a new project, which I've put into an empty directory, and we say it's TypeScript. And what we want to do first is to create an HTTP starter, and we call that, how do we call it? The onboarding. No, that's the onboarding starter. Here we go. So let me copy that over. We put it to anonymous, and that's already the first function that gets started. That's the entry point of our request. And what we will do here is basically receive the information of the onboarding employee, or of the employee that is to onboard. And this will be a JSON file that contains the name, the email, the start date, and the role, picking just some attributes that make sense. And this will then be forwarded to the orchestrator and to the activities. And as usual, our starter function is the entry point. Now, we will not change too much in that function. What we will do is we will say, hey, I just want to allow a post. So I go to the function.json, which is the configuration, and that's all that we do in order to get things started. Now, what we will do now, kind of in between, is, as you can see, those red curlies here, there is something missing. So I will first do an npm install the basic dependencies. Then the durable functions thingy is still missing. So I need to npm install durable functions. So that's the second thing that is needed. And there is also one other thing that is necessary if you want to do TypeScript. and that's the types node dependency, which is a def dependency, so we can do a save def. So we don't need that in the running system. We just need it for the build in order to have the types available. And as you can see here now, nothing is red anymore. That's good. And we can move on. Next step, of course, we need an orchestrator. So what we will do now is we add an orchestrator function. We call that one onboarding orchestrator. And well, that's it for the moment. We will adjust the code in a second. I will just create the 3 activities that we want to kick off from that orchestrator. And then we will walk through and adjust the code step by step. So what we'll do now is I want to add an activity. And I want to call that access card creation activity. First one, that is very cumbersome. The second one is called IT equipment. And the last one is called activity. So now we have, when we switch to the overview, we have the starter, we have the orchestrator, and we have 3 activities. That doesn't look too shabby. So we can start or nearly start. There is one thing that I forget in approximately 80% of the cases. When you do a local development, you have to point the Azure Web Job storage to your local development storage so that the storage emulator is targeted automatically. Let's do that away. And now let's get things started. So as I said, let's first start with the orchestrator. Here we will first get rid of all the unnecessary stuff that comes from the templating. And I do not like semicolons in TypeScript, so I remove them too. So that looks good. I have a GitHub Copilot active, so it already has some ideas what we might do, but they are wrong. So let's start with the first thing that we need is an array with the onboarding tasks. That's kind of something that you might remember from the last time, where we had activities and we pushed them out one by one. And we said, or we used the keyword yield. We have a generator function. So after each step, the iteration was stopped. What we want to do now is we want to bundle the tasks, throw them over the fence to the durable orchestrator machinery, and let it do its thing. So what we will do now is we will simply push the tasks onto that array that we just created. And we will do so by using the context that we get and use the durable function property on top of that context. And then we say, do a call activity. We do not use the yield keyword. We just put this activity call within this array. So that's it. And in order to make no typos, I copied that stuff. Let's move that away. You should see my screen in reality where I'm sitting. It's huge letters. So I have to juggle around a bit, but that's okay. And then we do the same for the other 2 tasks. So we have the access card creation, we have the ordering of the IT equipment, and we have the welcome email activity that we created before. And what we do is we simply push them onto the array. So that's all. And now we have an array of activities. And what we want to do, of course, now is we want to execute that, right? So we say, okay, I expect a result. And now I need the yield keyword because I have to do that. And now Copilot is really helping me. I will now tell the context and the durable function environment to execute all tasks that I put onto that array. Now, if you are working in the JavaScript or TypeScript area, then you might know the promise.all concept. So you push promises and you wait until all promises are resolved. The concept is the same here. So I have a task.all. This context will now execute all the activities that I pushed on top of it and wait until the results are returned. Now, in contrast to promises.all or promise.all, this can be distributed over many virtual machines. So this can scale out. And that's exactly the mechanism that is used within Azure in order to scale out the single activities to different virtual machines. And the durable functions extension will then make sure that there is a resilient end-to-end execution of all those tasks. So there is not that when a virtual machine goes away, you're not that lucky and you will not get nothing back from that activity. This is safeguarded by the durable function execution environment. And then what we want to do is we want to return the result. That always makes sense. That's good. And that's already it for the orchestrator. So we have now already modeled from an orchestrator perspective this parallel execution, this fan-out, fan-in pattern. That's all you need to do. Now, with the activities, as I said before, we will do some super highly sophisticated logic in there. First of all, we'll rename the input parameter to input. Because name is, I don't know who thought about the template, but
that is a very weird default input argument name. Yeah.
Yep. But there is a template, so let's be happy about that.
It's open source, right? So we should make a contribution to it to change it.
I think that might be worth it. Yeah, absolutely. So okay, and now we get in this JSON object with the parameters, with the name and the role and the start date. And what we will do is we will do a super highly sophisticated messaging that we execute. We do some logging, we return the message so that everything went through. And we will now do this exercise for all the other activities. So if you need to grab a coffee, then this is basically your chance. Let's go on input, and then we have the IT equipment. We clean up again.
So if you do this thing quite often, then it might be useful to actually make your own code snippets. So that's what I've done for .NET-based durable functions. I just made a couple of my own code snippets.
That makes perfect sense.
Some of them are a bit easier to use than the default.
That's perfectly right. Yeah. And the rest of the pipes is less. And when doing it like that in a live stream, we have now the welcoming message. So that's the last one. Go back from grabbing a coffee. And that's basically it. So we have now everything in place to check if our very first orchestration, parallel orchestration, will work. So what we will do as a first step to kind of safeguard if everything what we did is okay, so we will do npm run build, which holds the predefined script, which basically does the transpilation via TypeScript, and an npm install. no npm install, just a transpilation to see if everything is okay. No typos in there or something like that, so that works. And now, before we start, I will start Azure locally with the VS Code extension, which will give you some files within the folder where you started. Due to a pull request, the git ignore now takes care of them. That wasn't always the case. So if you still see them tracked via Git, update your extension. That creates the structure of your functions, because that git ignore file was enhanced. I will not tell you by whom. And then we can do an npm run start, right? So we have Azure running. We kick things off. And if we're lucky, the functions will start. So as you can see, I'm running Core Tools in version 4. It's the same within, and that's something that happens from time to time. At first start, somehow the processes are not really starting as smooth as the runtime expects it. That's kind of temporary, and I have no idea when that happens, but sometimes it happens. No panic, just restart it, and as you can see, everything runs through smoothly. And as you can see now, we have the activity trigger 1, 2, 3. We have the orchestration trigger, and we have our endpoint exposed as the onboarding starter. Now, I have already copied over the request.hdp file that we also provide you in the GitHub repository, which contains the calls. And as promised, you can do a lot of things with the calls. You can reference them, you can give them IDs, and then you can interact with the responses of that request that you named. I partially knew that, but Mark kind of did some black magic there, and that's a game changer for durable functions, because you do not have to mess around with the responses, which is just cool. So what we will do now is we call our orchestrator, and let's see what happens with a person that you might know. So you do not only learn about durable functions here, but also about great Netflix series that you should watch. And as we can see here, it was accepted. So we get the default response page. And we now fetch, as you can see here, with this magical handling of the response body, our status query URI, and make a call against that one and see what happened. And what we see here now is that the access card was created, the role-specific IT equipment was ordered, and the welcoming email was sent out. So everything was executed as expected. We would also see that in the console output. Mm-hmm. And now let's see what happens within the storage emulator. Mark, you have to tell me if it's big enough.
I think so. Yeah, looks good.
Okay, so as you know from the previous lesson on durable functions, we have those two tables that contain the instances of the durable functions that have been executed, and then the detailed history of each instance that is identified by this partition key, the GUID. We see the input, we see the onboarding orchestrator, so nothing different on that level when it comes to the different patterns, at least until now. And then we have the history table, and if we check that one, let's see, let's sort it. Yeah. We will see now that the execution started and the orchestrator started. That's business as usual. And then the orchestrator just scheduled the tasks. So he just executed those 3 tasks that we handed over with this .all method that we called. And then the orchestrator sets itself to sleep, and the tasks get completed, and the orchestrator wakes up and does its thing. So returns the information to the caller or to the status page, more or less, and the execution is completed. So that's the way it goes. And as you can see here, there is no sequence in there. So it can happen whatever comes first, kind of. So as you can see here, the role-specific IT equipment was kind of, it seems so, finished before the access card was created. Nevertheless, the first activity that we pushed onto the array was the access card creation. It's parallel. We do not care which comes first. There is no dependency in between the activities, so we just let them run through.
And it's not necessarily that everything is done in parallel, but it's definitely done asynchronously, right? So it's done as much as parallel as the system can handle, but yeah, it's definitely not in any sequence.
Yeah. So the important point is you cannot expect a sequence there. If you need a sequence, you have to put another pattern here. If you don't need a sequence, that will help you with scaling or will enable a scaling out. And as Mark said correctly, as far as it's possible. So that's what's happening there. And that's already the first pattern. So that's already done.
Nice.
In the books.
There's one small addition there, because we now just did 3 tasks, but you can use this as well for 100 tasks or 1,000 tasks. So these 1,000 tasks will not again be executed all in parallel, but some of them will be, let's say, executed in batches or as close parallel as possible. But it's important to realize that the orchestrator will, once the tasks are scheduled, the orchestrator will indeed go to sleep, and it will periodically check how many tasks have been completed. And depending on, of course, how many tasks have been scheduled, it might take a couple of iterations of going to sleep and coming back alive. But once all the tasks are done, then also the orchestration is done.
Exactly. So that's also one important thing, because this is something you have to think about. And good that you mentioned that, Mark. When analyzing the steps on database level. So there might be a bit more steps due to the fact that you pushed out 1,000 in parallel, which might make analysis a bit more difficult. So that's something you have to keep in mind. So it's a price that you pay for that convenience, so to say, when you have an error somewhere. Yeah, first pattern done.
Nice.
So we can execute activities in parallel. We can execute them now in sequence. We can execute them in parallel. That's cool. Now, as Mark already kind of introduced, you might have a lot of parallel executions of those activities, or you might want to have some building blocks. Let's say you do not only have one person that you want to onboard, but you have multiple persons that you want to onboard, and you want to reuse this orchestration. So you do not want to iterate yourself across that list of employees that you want to onboard, but you want to hand in that list to your durable function environment and let it do its thing. And you want to reuse this little building block that we just created. And for that, we will use the so-called sub-orchestration. Going back to the Excaligraph, what we want to do is we want to send a JSON array to our durable functions endpoint with a list of employees to onboard in there. And if the series wasn't clear until now it should be. And with that, we want to spin up sub-orchestrations. So we want to we use this setup that we have created before with an orchestrator calling 3 activities in parallel. And we want to have a super orchestrator in front of that simply distributes the stuff. And that's the so-called sub-orchestration pattern. So we have one main orchestrator, which triggers several sub-orchestrations. And those sub-orchestrations then trigger the activities. So in order to achieve that, what we will do is we will create one more orchestrator function, which will then serve as this, I don't think it's a name, super orchestrator, or however you want to call it.
Yeah, I usually call it main orchestrator, I think. But
the main orchestrator, yeah. So which executes the sub-orchestrations in parallel, again, with the restriction that we just discussed. And there are some restrictions with respect to scaling out. I don't have them at the top of my head, but if you have really a large amount of stuff to do, so to say, check the documentation, because there are some things to keep in mind around that. Okay, so we have another orchestrator created here, which will get this JSON array as input, and which should trigger the sub-orchestrations. There is some restrictions, so that we also mentioned in the first lesson. So, for example, only starter functions and orchestrator can call orchestrator functions. So that's kind of something that is checked. And what we will do now is I will copy that and then walk through it. Basically, we will do exactly the same pattern that we did before. So we expect this employees to onboard array to come in via the post request. And if there are entries within the array, we will iterate over those. And what we will do is we will now not push an activity on top of an array that should be executed at some point in time, but we will push orchestrations on top of that. So what we will do is we will create an array, the onboarding list. So all the employees will be put on that list. And what we do, so let me show that. What we do is we, let's focus on that one. We execute the so-called call sub-orchestration. And the call sub-orchestration is another method that you can call, and that gets the name of the orchestrator as input, some data, and when you take a look at the description, I mean, data is optional, so if there's no data, nothing to do. And there is one third optional parameter, which is the child ID. That's an optional parameter, which identifies the sub-orchestration. If I remember correctly, by default, it's the instance ID of the orchestration per se, so the GUID, and the number that's counted upwards. Yeah. And what's important about that is that this needs to be unique. As you can see here from the description, it's a unique ID. What I do now is just for the sake of demo. I create this child ID by myself, and I do not really care about the uniqueness because I know the input parameters. So what I do is, in order to see what's happening behind the scenes, I take the instance ID and then just append the name of the employee entry that will be created. That's nothing that will work in reality, but this will help us when we look into the database. And with that, we have now this array, this list of the onboarding entries, or the list of the orchestrations, so I have to say. Mm-hmm. And what we will do now is, again, execute and yield. So we do the same, we call the same method, so to say, on the context, on the durable functions context. We say tasks all, but this time we hand over the onboarding list, which consists of sub-orchestrations or orchestrations. And that will work. Now, or hopefully, let's see. What's to be kept in mind is that the sub-orchestrations, and I also reference that in the documentation, must be defined in the same function app as the parent orchestration. So with respect to the, let's say, building blocks and reusability, it's not super perfect, but it's okayish. So you can have them in one function app and then reference them. That already helps. But you cannot distribute them across function apps, so that's not possible. What we will also do now is, that's something that's, I think, quite useful when you want to do debugging, a little info message about how many sub-orchestrations have been spun up by just checking the length of the array. And if you remember the first session, what we do is we check if this is the first execution of the method, which is caught by the durable function context via the isReplaying parameter. If that is false, then we throw out the info. If it's in a state where it gets reiterated, isReplay is true. So we will not log that. So to not clutter the log. And I think that's already it, right? Yeah. So just shortly recapping, we get a JSON array as an input. We iterate over the JSON array and fill an array with orchestration entries or sub-orchestration entries by using the call sub-orchestrator method on the durable functions context. And then we basically say again, hey, execute that stuff for us, and we're good to go. Okay, then let's check.
Technically, there's no real difference between a main sub-orchestrator or a main orchestrator and a sub-orchestrator, right? It's the same type of function. It's just that you can easily, let's say, group some kind of functionality into an orchestrator using sub-orchestrators. If
you take a look at that, so that there is no difference in the configuration exactly.
Yeah.
So it's an orchestration trigger. That's all of relevance for the runtime. So you cannot distinguish that. That's also important. So if you just take a look at the code, you cannot see if it's by just looking at the configuration if it's an orchestrator or sub-orchestrator. That's not possible.
Yeah, so once you start it, it will list like orchestrator twice, and you wouldn't know which one is the main and which one is the sub, and no, that's only visible inside the code.
So that's where I think naming conventions make sense also a bit in order to see what to have there. So let's exercise then again if we made any typo. No.
You can copy and paste so well.
I mean, that's the art of a senior developer, right? Copy and paste. Like a boss. So now let's see how the durable function runtime will present us the new instance. And yeah, Mark already spoiled that. You just have another orchestration trigger.
Oops. Yeah.
So that's it. So you have now 2 orchestration triggers, you have 3 activities, and you have no idea how they correlate. So there's nothing there. Perhaps that's also a good point in time to mention the durable functions monitor add-on or extension that you can use, which can help you with that, visualizing the executions and so on. So that's also a super valuable extension. It is now available in the Microsoft GitHub organization, I think.
Yes,
and helps you a ton with analyzing and visualizing the executions.
I'll put a link in the description later because it's a very valuable tool.
Yeah.
Good point that you mentioned. Thanks.
That's cool. Okay. So let's move on. So again, now we will call the parallel execution, and we will call it with an array of JSON objects. And yeah, we will get the very well-known status page. Due to this, still for me, game changer magic, we can now get the response. So we get a 200 OK. We get the input. We get the status, which is completed. Well, we do not get any output because we didn't return any output, right?
Yeah.
So we just executed the sub-orchestration.
Yeah.
It looks okay. It seems to have completed, but the truth is in the database. So let's check that. And what we see now already is we have now for each orchestration, be it a main orchestration or a sub-orchestration, one entry within the test hub instances table. And now you see why I changed it to the name. You can now exactly see which sub-orchestration deals with which employee. We have this main orchestration, this gets the array, and we have the sub-orchestration, and that looks exactly like the orchestration before. Yeah, because it's the same orchestration, right?
Right. Yeah.
And this now also has some implications on the history table. Let's make that a bit smaller. The 3, that's the one that we are looking for. So let's move that up. That's the main orchestrator that we kicked off. Mm-hmm. And as you can see here, the event type now clearly states what's happening. So a sub-orchestration instance is created, not an activity is triggered. And as you can see here, the sub-orchestration starts immediately, then the second sub-orchestration is created, and the third one is created, and the orchestration completes. And all the other executions start. And as you can see here, this checks, the orchestrator started, sorry, no. The orchestrator started for the sub-orchestrations.
Yeah, this one for Rollins. Yeah, exactly. Yeah.
We're now one level lower. So we are at the sub-orchestration instance level, but of course it's an orchestration. So now the fun starts because now you have to check partition key, event type, and so on if you need to analyze something there. So this can get not so nice if you have an error there. And then you have the task scheduling. And of course, if you think now, we started with one main orchestrator, we spun up 3 sub-orchestrations, which each spun up 3 activities. Now think about that with a factor 10 or 100. That's not so nice to analyze. If it runs, it's great. But if it doesn't run, that's not so great. And as you can see here, all the things repeat itself. Everything gets executed. So the task is executed. The orchestrator at some point in time, or the sub-orchestrator, I have to say, completes. And then moving again up one level, the sub-orchestration instance is completed. Second one, the third one, and the overall orchestration comes to an end. As you can see here already, that's what Mark mentioned before. There might be some starts of the orchestrator, and he sees, not everything is finished, so I complete again, and then I wake up again, and then complete things again when everything is done. So that's kind of already a more powerful, but also more complex pattern with durable functions. Because as you see, you can really do quite some stuff with this pattern, but if you have a bug somewhere in between and you have to analyze on database level, yeah, there is some work to do.
Yeah, well, that's really where the durable functions monitor, right? That dedicated tool for durable functions, that's where it really helps. So I definitely used that monitor tool for a couple of times, where it was much easier to navigate the history table than just
That's
looking
where
at
the
here.
power of this tool comes in, yeah, because
Yeah.
you have the visualization,
Yeah,
and you can then dive into the single instances.
exactly.
So you can really move forward and backward by just meditating about this table will not give you the solution.
Yeah, indeed.
No way.
The monitor tool is very nice for also filtering based on date or based on names or based on status of orchestration. So it's really useful.
Exactly. So that's really, really great. Great tool. Yeah.
And in general, maybe it's also useful to say, this is a very useful pattern, but use it wisely, right? Don't go like more than 3 levels deep. I didn't even go further than 2 levels deep, like this example, because it's very hard to navigate the code as well. Then.
Exactly. So it's really a powerful pattern, but use it wisely. So it's like with design patterns. So don't throw them just because you know them at every problem that might fit.
Yeah.
Also respect some constraints when it comes to scaling out, because this will hit you hard when you have several levels there. And that's something that you have to keep in mind.
Yeah. Okay. Nice. Yeah.
That's already the second part. So let's move on to the last one. Thinking about something like a workflow. When you have ever designed something like a workflow, you will always come to a point where you have to have some external interaction, and in most cases, human interaction. Because there are this 10 or 20% of cases where the automaticity doesn't work, or the rules that you would have to put on top in order to model the business workflow become too complex. And then it's simply more efficient to have a human being looking on top of it and saying, okay, that's fine or that's not fine. And there is an option within durable functions to do so, which is called external event. So it's more generic. It's an external event that you can fire against your durable functions, and the durable functions will react on them. We will see the mechanism in a second. And we will model that by saying, okay, if I have an employee who has a specific role, he might not be allowed to exceed a certain amount of money to spend on IT equipment or something like that. I put sales as a role because who likes sales? And just kidding. And we will then see how we can model that. For that, we will do a modification, or we will, to be honest, introduce a new activity, which will take into account this approval needed process step. So we will check the IT equipment value by role activity. So we will check if it's okay to order the IT equipment, or if it's not okay. And as you can see, we will do the same thing that we did before. We will first put in input here. And then what we will do is, and we will make it even easier, we will say whenever there is somebody of sales wanting to order IT equipment, they need an approval. That's kind of the hardcore way to do that. And then we will also create a new orchestrator, because we now do not need this parallel execution in order to see the effect of external events. So we will create a new orchestrator called onboarding orchestrator external event to distinguish it from the other ones. To, of course, again, clean up. And what we will do now from a logical perspective, we will first call this newly created activity to check if we can order IT equipment based on the role that we got in from the caller. If we are not allowed to do that by the automatic workflow, we will say, okay, then let's wait for an event to happen that will allow me to order that equipment, or that will tell me, no, that's absolutely not okay to do that. We will now not trigger any outward going information in order to trigger the workflow and send out emails to the responsible parties. We will just assume they know. So what we do is we this time do a yielded activity call. So we will call the check IT equipment value because we need the result of that activity in order to decide how to move on. And depending on the check result, we will see what we will do next. And if the check result, so if the activity tells us, hey, it's not approved what you want to do, which is returned by a string. So as we said in every lesson, take that with a grain of salt. So that's not production grade. But makes things a bit clearer here. We say, okay, then please wait for an external event that is called approval request. And if this this event or this task, so it's again a task, is returned, and this task has a default attribute called result. If the value of that result is approved, then we approve the order. If not, we do not approve the order. That's basically it. Now, if we would now spin up that durable function, we would call the first activity, and then we would wait for an external event. And if we would not raise the external event, we would wait basically for eternity in our local execution environment.
Yeah.
That's not ideal. So what we have to do is we have to implement a pattern that we had in the first lesson, which we called then the circuit breaker. So we will now introduce a timer. And if the timer is running and some grace period is over, then we will abort the flow. And if the approval task or if the external event is raised before the timer is up, we can continue with working. Now we will do that by making use of another utility called lookZone. Now, if you we of course have to install the dependency. If you're looking at the documentation of functions and durable functions, there are those code snippets, and there has been moment.js in there before. Don't use moment.js. Even if you have some old code snippets, moment.js is highly deprecated. So there is very little maintenance on that. So there are other solutions out there. I usually use lookZone because that also has a migration guide. So if you are working with moment.js and want to migrate your code to lookZone, there is a very clear instruction which command transfers to what command.
That's nice. Yeah.
I think the documentation and the code samples of Microsoft are now also using lookZone. I just know that one pull request is pending.
Okay.
So you should now see only lookZone because that got on my nerves, to be honest. But one pull request is not merged yet. So
okay, yeah. I see it in it now in the Azure docs. I see indeed human interaction sample using lookZone. So there it's fixed. Yeah.
That's fixed. Yeah. That was a code sample that was merged quite quickly. The other ones seem to take a bit longer.
Okay.
So what we have to do in order to implement that, we have to get rid of the yield, of course, because we want to have two tasks again. So we need the approval task and we need the timeout task. So basically, what's important here to mention is that we use the current UTC datetime from the durable functions context, because that's the only one that's reliable. And then we massage it a bit and add 90 seconds and do that as a timer. So that's the expiration point in time. And with that, we create a timer, which gives us back the timeout task. We have the approval task. And what we then have to do is we have to decide who wins. And I will then now just blindly copy the rest.
Yeah, so both the approval task and the timeout tasks will start executing, and whichever one completes first is the winner task.
Exactly. So that's something that you probably should have in mind still from the first lesson. So that's the task any. So before we had the task all, so we waited until all tasks have returned. This is now the durable function orchestrator will wake up when the first task is returned and will kind of take that and move on with the processing. And we say, okay, if the winner is the approval task, then we say, we kick in with the logic, was it approved, was it not approved, and continue. And in the other case, we say, hey, timeout, bad luck. And if we run into the situation where the approval task is the winner, we have to manually complete the timeout task. So we have to do the timeout task cancel. That's important. Because otherwise you might run into some situations that are at least weird. And then we have to complete the logic, because we have, of course, at some point in time then to order the IT equipment, right? So to make it complete. So now is we say, okay, either we have the original check result, which was approved, which comes from our activity, or the manual interaction or the event was received and the order is approved, then we order the IT equipment, or the order was declined, then we say, sorry, order was declined. Or if the timeout hit, because then also the order was declined, kind of, and we return that to the caller. So then we have really the complete flow. So from checking if we can order it to, okay, we need to wait for an external event, but we will not wait forever. So we have this timeout task. And then depending on the outcome of all this, we either order something or we do not order something.
Yep.
And yeah, that should do the trick. So what we'll do now is, let's start off. I'm sure this time I made an error when building it, right? Because I do not run build before. Let's keep our fingers crossed. Looks good.
It starts, yeah.
Starts. Okay. And now, as of course, we have it in the same project. So we have now a bit of overhead there, because basically what we need is the onboarding starter. We need our onboarding orchestrator for the external event, which executes the orchestration that we just implemented. And we need the check IT equipment value by role activity, and of course the IT equipment order activity. The rest is not used in this sample.
Yeah.
And then, yeah, we have to do the call. Where are we? Here. So it's exactly the same. We just hand over the different name for the orchestrator as we did before. hand over the parameters, and this time we made sure that the if statement is hit in the right branch. So we say it's the role sales, and when we send that, we get the status page. And if we now fetch the result from the status endpoint, we will see that it's still running.
Right.
So it did not finish, and it's not because it's taking so long to process. It's just still waiting for the event for the approval, exactly. Yeah. And then the approval is something that you can also call via one URI that is returned from the status page that we reference here. And we say the event name is approval request. That's what we implemented. That's what we are waiting for. So if I quickly move over here, we have this event approval request that we are waiting for. That's what we hand over here. And let's send it before the time runs up. So it's accepted. And if we now check what's happening is role-specific IT equipment was ordered. So everything is fine. We see all the execution that is happening afterwards, but there was quite some delay because we waited a bit. So here we had the start round about that, and then the execution was happening later. And the same is visible within the tables. So what we have here, and I will now copy that one to do a little query. To have less noise there in that one. And we sort it. And as usual, things start, the task gets scheduled, a task gets completed, and this task now basically says that where was it? Approval is needed. I just follow it. So that's the point where the timer gets created and the task gets scheduled. And then, as we see, the event gets raised because we from externally triggered that one. And then the remaining orchestration runs through. So this is then the ordering process that takes place. And everything is returned as before.
Cool.
Now, we can also shortly check what, just to show you that there is no trick sleeve. We just put that to let's say 5 seconds.
Oh, you want to time out? Yeah, okay. Yeah.
So that you see that we are indeed running into timeout. So we restart it. Everything's going on. So again, everything is up and running. We do the request, and we send it again. And this time we just wait a bit. 5 seconds. That's okay-ish to wait. And you see timeout is expired and the order was declined. That's working. So if you play around with that, you of course you can change the event name. You can change the message that is handed over from approved to not approved or whatsoever. If it's not approved, then it's not approved. If you put something different in here, and see how things act. And I would really recommend you to play around a bit, because that's also a quite nice pattern that you can use with durable functions, to be honest.
Yeah, this one, I think I used this once when I was talking to also an async API, and you could configure a webhook at that side. And so whenever a process was done, that webhook was called, and that webhook then pointed back to the function app and triggered this event.
That's a perfect other example. So that's also why it's not called human interaction.
It's not human interaction per se. No, exactly. Yeah.
It's called external event. So it's waiting for an external event. So scenarios with webhooks, for example, are a perfect example for also making use of this pattern.
Yeah.
Which allows you then to integrate durable functions with webhooks, which is also a quite nice thing to do. And yeah, that's it for today with durable functions advanced patterns. So yeah, we had now another bunch of thingies around durable functions. So we had the fan in, fan out, fan in pattern. We had the sub-orchestration, and we had the waiting for an external event with the example of a human interaction. And now, in order to give you the option to do some things there, I will make that a bit bigger. We have, of course, again, a homework assignment, which guides you through the same patterns, but this time from a scenario perspective with going to a conference, when going to a conference is possible again. Namely, buy a conference ticket, book a hotel room, and book a train ride, which you now can exercise to do the fan out, fan in, do the sub-orchestration, and so on. Yeah, everything that you need to know is there. Everything that you might stumble across, like the local settings.json with the storage is mentioned here. If you do that exercise, if you succeed, or if you have some experience with it, we're happy to hear from you on LinkedIn, on Twitter, as mentioned here. And if you walk now through that lesson by yourself, if you want to dive through the code, there are some things that we would like to mention that you can use in order to make your, where do I go best? I just go here. Make your experience a bit more smooth. So maybe you know it already, maybe not, then that's great. We have workspaces. So if you clone the repository, you do not have to open everything and navigate to the right spot within the repository and then look at the code. We have workspaces for that. So we kind of group the right directories, and you can open that workspace with VS Code, and it will pull together the right folders and also have some naming upon it. And then you don't have to deal with the noise of the complete repository. That's one thing that's worth to mention. And the second one is everybody learns different. So if you would like to step through the code in a guided manner and want to have the description of the code side by side with the code, and we also got you covered with so-called code tours. That's an extension within Visual Studio Code. And for some of the sessions, we have the tours, which allow you to step through the code step by step and digest the code that way. What you will see if you have the extension installed is a little snippet down here, CodeTour. And if you open the repository, it will already pre-fill the CodeTour section. You can start the CodeTours if you have opened the workspace, because there is some dependency with respect to referencing the files. But then if you have opened the, did I say CodeSpace? The workspace. If you've opened the workspace, you can step through the CodeTour and digest it that way. So that's something that might not be super well known, but I think is a nice thing to try out. Yeah.
Exactly. And I will show here somewhere a dedicated video that explains the concept and how you should actually, or how you can consume the lesson in various ways using YouTube, GitHub, and CodeTours and workspaces. So I'll link to that as well. Cool.
Okay.
Thanks,
Yeah.
Christian. It was a lot of information again, but yeah, I love to hear from this always. It's still really one of my favorite frameworks, durable functions.
Yep.
Cool.
Same here.
All right.
Cool.
Well, again, if you have questions about this, please let us know. We're always happy to help, and always very eager to see what you do with the homework. So please let us know as well. And if you want to contribute in any way, please go to the URL of the GitHub repo, make an issue there. Also, if you want to reach out to us on Twitter, that's also fine, about contributing or having new ideas about lessons. We definitely want to continue this more and more, also across the various languages that Azure Functions support. So we'll keep doing this for a while.
Will
all right.
keep us busy, yeah.
Exactly. Yeah. Right. Well, thank you, Christian, and thanks everyone, and see you until the next lesson.
Thanks
Bye-bye.
everyone for joining. Yeah. Bye.